Assalamualaikum warahmatullahi wabarakatuh, and good morning teachers and friends. First of all, I would like to say thank you all for coming to see this video for today. As you can see on the slide, today I want to talk about chapter 6 and the title is machine number. And for those who doesn't know me, my name is Muhammad Shauki bin Muhammad Sukri, and this is my friend and his name is Muhammad Nasrul bin Muhammad Zaidi. And this is the content that we are gonna learn for today. And first, we gonna learn about the introduction. First, before we learn about the machine number, we have to know what is computer arithmetic. The computer arithmetic is a field of computer science that investigates how computers should represent numbers and perform operation on them. It refers to the process of performing arithmetic operations on numbers represented in binary form using fixed length sequence of zeros and ones. And this is the introduction about the machine number. Machine number is a computer represents numbers and integers in binary, which is 0 and 1. And each binary value represents a numbers such as 0000 in the base of 2 will represent the number 0, and 0001 will represent number 1, 0010 will represent number 2, and so on. And next, there are three ways to differentiate positive and negative numbers. The first way is by using the sign magnitude, the second way is by using the ones complement, and the third way is by using the twos complements. For example, represent the positive 9 and negative 9 in 7-bit binary numbers. So, there are only one way to represent the positive 9, which is 000101. But there are three different ways to represent the negative 9. The first way is by using the sign magnitude. We got the 1001001. The second way is by using the sign first complement, which we will get the 110110. And the third way is by using the sign second complement, which we will get the 111011. Next, we're gonna learn about the signed and unsigned number. First of all, we have to know that computer cannot understand the positive sign and negative sign. So, in order for computer to understand, the computer will use the number 0 and 1 to represent positive and negative sign respectively. So, normally computer system use 8 bits to represent a character or a number. And this is the example of signed and unsigned numbers using 4-bit data representation. As you can see, without the sign, we will get the value 000 and 111, and its value is 0 and 15 respectively. The range is from 0 to 15, and with sign we will get the 1111 and 0111. The value is negative 7 and positive 7 respectively, and also the range is from negative 7 to positive 7, but the number of bits for both without the sign and the sign are the same. And next is the example when we are using the 8-bit data representation. Next, we need to learn about the disadvantages of signed and unsigned number. First, the disadvantage is when we are using the unsigned numbers and signed numbers, it will reduce the value that can be represented by the bits by half. However, the total numbers that can be represented are still the same. And the next disadvantage is when we are using the signed and unsigned number, it will cause errors in arithmetic operation. For example, we need to solve the problem using signed and unsigned numbers. The question is, what is the result of 0100 in the base of 2 plus 10101010 in the place of 2? So, when we do the arithmetic operation, we will get the 11110110, which is negative 118, which is the wrong answer. So, to get the right answer, we need to use the first complement method. So, I will pass to Muhammad Nasrul to teach about the ones complement.
So, moving on to the ones complement or the first complement. The first complement is another binary number that is obtained by toggling all bits in the number. In the first complement format, the positive numbers will remain unchanged. However, the negative numbers, we can obtain it by taking the first complements of the positive counterparts. For example, the number 76 will be represented as 01001100 in 8-bit notations. The negative 76 will be represented as the 10110011, which is the first complement of the positive number of the 7 bits in binary form. So for further understanding, there is another example here, which is the first complement of 0111 is 1000. And another example is that 1100, the first complement form of it is the 0011. So here is some example for the solution for the ones complement of the first complements. So here, as you could see, that we use the equation of 76 plus negative 42. So the first step is we change all the number here to the binary form, which is 76 to 01001100, and the 42 to 00101010. And then move on to the second step, we change the negative 42 binary form into the first complement, which is it will be 11010101. It become like this because for the first complement, when we need to change it, we just need to invert the binary form of it. So for the second step, we just need to change the binary form of the 42 into the first complement. So how to do it? We just invert all the number here, which is 0 to 1s and 1 to 0. And it will become as shown here, which is 11010101. And we move on to the third step, which is we just need to add both of the number, and it will be resulting to 1001000001. And here we need to carry the 1 at the leftmost part, and then we carry it to the step 4. And here we add around the carry, and we plus the number 1 with the remaining 8 bits in the number previously, which is 00100001. And plus which one, it will become 00100010, which is in the decimal form, it will be 34. And this is the final answer. The disadvantages of the first complements is that the problem when representing the number 0, as to when 0000 in first complement, it will be 1111. And the second one is that overflow could occur in certain arithmetic calculations. So moving on to the second complement, it is just another mathematical operation on binary numbers, and is how most digital systems store numbers. It is used to signal a positive or negative integer in binary. So to get the second complement's negative notation of an integer, you write out the number in binary, and then you invert the digit, which is what we have done in the first complement, and from there we add 1 to the result to change it to the second complement. So here is some examples. Suppose we want to change the negative 42 to 2 complement, the second complement. So first we change 42 to binary, and then the binary you invert the digits, 0 becomes 1 and 1 becomes 0. And then from the first complement there, we add 1 to it, it will become 11010110, and that is how negative 42 in 8-bit binary to complement form is. Then here is some example for solution for the second complement. So here we just use the same equation here as in the first complement, and then the first step is the same as the first complement as well, which we change all the number here into the binary form. And then for step 2, we change the negative number needed here as 42 in binary form into the first complement first, and then we add 1 to the first complement form to change it to the second complement, and it will be resulting to 11010110. Then moving on to the step 3, which is we just need to add the numbers same as before, and it will resulting to 10010010. And here we could see the number 1 at the leftmost, and it is the overflow. But however, the overflow in the second complement, we just need to ignore it, which is then we just keep the 8-bit form of the number 00, which is 00100010, and it is our final answer, which is equal to 34 in decimal. So to conclude, in understanding how computer represents the integer, it is essential for us. Moreover, the second complement is widely used because it simplifies the arithmetics and avoids the problem of having 2 zeros.